How many rectangles do you see? Hi, I'm Roland from Math Geeks R Us, and I'd like to share with you my solution to this riddle, as well as my quick and easy method to solve this type of problem in general. Let's face it, we've all seen this type of riddle on Facebook, and we spend 5 or 10 minutes pointing at the screen, counting in our heads, trying to get the right number, and then posting it only to have someone else tell us we've got the wrong number, so we have to go back and spend 5 or 10 more minutes finding all the rectangles they thought we missed. Wouldn't it be nice if there was a way to get the right number of rectangles every time in less than 10 seconds, without counting, using only second grade math, in our heads? Well, there is a way to do that. Before we start, let's get a couple things straight. First, the word rectangle in the question does not count as one of the rectangles. Second, a square is a special type of rectangle with 4 equal sides. Squares do count. Third, you can combine adjacent squares and other rectangles into larger rectangles. That's the whole point of the exercise. Now, before I show you how to solve this riddle, pause the video and see if you can count the correct number of rectangles. How many did you get? All right, let's have the computer count them for us. Did you get all 90? Don't feel bad, because most people don't. Let me show you the process I use to determine the right number every time. Let's pick 2 random points from this grid. And notice that those 2 points are opposite corners of a rectangle. That's one of the rectangles we need to count. Here's another pair of points and the rectangle they create. Now, do every pair of points create a rectangle? No. In some cases, they only create a line. Here's 2 points that only create a line. Here are 2 more that only create a line. In order to create a rectangle, we need to choose 2 points that are not collinear. Collinear is a mathematical term that means in the same line. So if we have 2 points that are in the same line, they're not going to create a rectangle. So we need to choose 2 points that are not collinear. So if we can find all the pairs of points that are not collinear, we have a means to find the total number of rectangles in the grid. Here's another rectangle. Notice I've colored 2 of the corners. The blue corner we'll call the primary corner. The opposite corner we're going to color red. Any point in this grid can be the primary corner of a rectangle. So how many primary corners are there? Well, we have 5 squares along the top. That means there are 6 points along the top. We have 3 squares along the side. That means there are 4 points along the side. 6 times 4 equals 24 points. So there are 24 possible primary corners in this grid. Let's choose one of those primary corners. How many other points in our grid could be an opposite corner to this primary corner? Remember, we need to choose points that are not collinear with our primary corner. So how many are left? We had 6 along the top, but we removed one because it was collinear with our primary corner. We had 4 along the side, but we removed one because it was collinear with our primary corner. That leaves us a grid of 5 by 3 possible opposite corners for a total of 15. So each of our 24 primary corners could have 15 opposite corners. 24 times 15 equals 360 possible rectangles. Now, why did our calculation end up with 4 times as many as the actual answer? It's almost as if we counted each rectangle 4 times. Well, actually we did. Let's go back to our random rectangle. Notice that that primary corner could be any one of 4 possible corners in that rectangle. Each of those 4 possible variations creates the same rectangle. So we need to divide our total calculation by 4 to arrive at the actual answer to the riddle. Let's go through our example again, but this time let's leave out the math until we get to the end. Here's our blank 5 by 3 grid. Remember that the number of primary corners is always going to be 1 more than the number of squares on each side. So that's 6 times 4. Recall that the opposite corners have to be non-collinear, so we're going to remove one column and one row from the primary corners to get the opposite corners. That gives us 5 by 3 opposite corners. Notice that the number of opposite corners is the same size as our grid, 5 by 3. And finally, we divide the answer by 4 because we counted each rectangle 4 times. So the answer to this question, without doing any math, is 6 times 4 times 5 times 3 divided by 4. Now let me give you another shortcut. Dividing by 4 is the same thing as dividing by 2 twice. And the way the problem is set up, we're always going to have 2 even numbers and 2 odd numbers to multiply together. So if we cut those 2 even numbers in half, then not only have we made our multiplication easier, we don't have to do any division. Now the answer is 3 times 2 times 5 times 3. Here's another cool trick. Anytime you have to multiply several numbers together, you can multiply them in any order. That's called the commutative property of multiplication. You don't have to remember that name, but it helps to remember that you can do this. So we can arrange those 4 numbers in any order we want and then multiply. Let's arrange them like this. 3 times 3 times 5 times 2. That makes our multiplication even easier because 3 times 3 is 9, 5 times 2 is 10, so you just add a 0 to the 9 and you get 90. Let's try another example and use all our shortcuts. Here's a 6 by 2 grid. Let's lay out our numbers. The number of possible primary corners is going to be one more than the size of the grid, so that's 7 by 3. The number of opposite corners is going to be the same size as the grid, so that's 6 by 2. That gives us 7 times 3 times 6 times 2. We can cut the 2 even numbers in half, so now we have 7 times 3 times 3 times 1. That's the same as 7 times 9 is 63. Let's watch the computer count those for us. Let's try another one, but this time without me narrating. Just watch the numbers. Here's one more without the narration. It even works on the simplest example. In this example, we can count the number of rectangles faster than we can calculate them, but it's good to test out our process to make sure it works in all cases. Okay, now I'm going to give you a few to try on your own. Pause the video so that you can try the calculations before the computer does it for you. Last one. This one's a little bit bigger, but we can still do it in our heads. That was quite a few specific examples. But before we wrap up, I'd like to give you the general formula. A general formula uses variables instead of numbers, so we can apply that formula to any grid and get the correct number of rectangles. Let's assume we're given an m by n grid. The number of possible primary corners is going to be m plus 1 times n plus 1. The number of opposite corners is the same size as the grid, so that's m times n. Then we just divide everything by 4. So the general formula is m plus 1 times n plus 1 times m times n divided by 4. Using this formula and a pencil, you could calculate the number of rectangles in a 76 by 32 grid. Thanks for checking out my video. The next time you see this riddle on Facebook, you won't waste 10 minutes of your life counting the rectangles. You'll only waste 10 seconds. And if the person who posted the riddle wants to include the word rectangle in the final count, tell them that's not math, that's just annoying. Be sure to click the subscribe button so that you know when the next Math Geeks video is available.